Hello, my name is Francisco Javier del Val Mora. This is Electromechanical Systems, and today I'm going to show you how to wire an LDR sensor using three different types of circuits. An LDR is a light-sensitive semiconductor, meaning that in its function, when it is exposed to more light, there's going to be less resistance, meaning that there's going to be more current flowing through the circuit, and vice versa, meaning that when it's darker, there's going to be more resistance, meaning that there's going to be less current flowing through the circuit.
Some of the items you will be needing for this project are a 9-volt battery, a power supply module, a breadboard, three 330 ohm resistors, one 100K resistor, 3 LEDs, 2 LDRs, some wires, and a transistor. This is an overview of the circuits I'm going to be wiring today. The first one is going to be a series circuit. The second one is going to be a parallel circuit. And the third one is going to be a circuit using a transistor. We're going to start with our series circuit. We have our logic truth table here. A 1 means that there's going to be light, and a 0 means that it's going to be dark. If we have an input of 1, the output is going to be 1, meaning that the LED is going to turn on. If our input is a 0, the output is also going to be a 0, meaning that the LED is going to be off. I did wire all three circuits on the same breadboard. We're going to start with our series circuit. We're going to start by plugging in one leg of the 330 ohm resistor to power, the other one to the breadboard. We're going to have our LED, we're going to have our longer side, the anode, connected next to the peg of the resistor, and the cathode, which is the ground, we're going to connect it to the other part of the breadboard. From there, we're going to connect our LDR with one leg on the same line as the one from the LED, and the other one is going to be connected to ground. We're going to test our circuit. I'm going to turn it on. As you can see, if there's light, the LED is going to turn on, but as I start to cover the LDR with my finger, you can see that the light starts to dim a little. And this is because of the specific way we wired the circuit. It's not going to be perfect. Our second circuit is going to be our parallel circuit. We have our logic truth table here. An input of a 1 gives us an output of a 0. An input of a 0 gives us an output of a 1. Meaning that if there's light, the current is going to flow through the LDR instead of the LED, turning the LED off. But if there's no light, the current is going to flow to the LED instead of the LDR, meaning that there's going to be light. This is our second circuit, the parallel circuit. We're going to start by connecting the 330 ohm resistor. One of the pegs is going to connect into power. The other one is going to connect into the breadboard. On the same line, we're going to connect one of the pegs of the LDR into it, while the other one is going to be connected into ground. And finally, we're going to connect our LED. Our anode is going to connect in the same line as the LDR and the resistor, while the cathode is going to connect into ground. Now it's time to test our second circuit, the parallel circuit. Let me turn on the power here. As you could see, the light is going to be on, but as we start to shine a light on it, it's going to be turning off. There you go, the light's shining on the LDR and the LED is off. And finally, we have our third circuit, the transistor circuit. We have our logic truth table here. If we have an input of a 1, we're going to have an output of a 0. If we have an input of a 0, we're going to have an output of a 1. Meaning that if there's light, current's going to go through the 100K resistor. Very high current is going to go to the LDR, but very low current is going to go to the transistor, meaning that the LED is going to be off. But if there's no light, current is still going to flow through both resistors, but very high current is going to go to the LED, meaning that it's going to turn on, but very low is going to go into the LDR. We have our third circuit, the transistor circuit. We're going to start by plugging in the 100K ohm resistor. One of the legs is going to be connected to power. The other one is going to be connected to part of the breadboard, which is also connected to a jumper cable, which is connected to one of the legs of the transistor, and also the LDR, which is also connected to the ground. We have our 330 ohm resistor, which one leg is connected to power, the other one to the breadboard. It's on the same line as the LED with its anode. The cathode is connected to another part of the breadboard, which is connected to the yellow jumper cable, which is then jumped into one of the legs of the transistor. And finally, the last leg of the transistor is going to be connected from part of the breadboard into the ground. Now it's time to test our circuit. I'm going to turn the power on. As you can see, the LED is off, But as I start to cover the LDR sensor with my finger, it should be turning on. And there you go, our circuit works.
Today we were able to wire 3 circuits using an LDR sensor. Thank you for watching this video and have a nice day.